Differentiating parametric functions. Two variables x and y are said to be described parametrically if the rule is described in terms of a third variable, called the parameter. Often t or theta is used. So what you might see is something like x equals t squared, y equals t cubed minus 1. Or a common one is x is cos theta, y is sine theta. And the third variable here is the parameter, and these are parametric equations. You may have met parametric equations before, for example with vectors. Reasons for expressing curves parametrically include: simplify complex relationships, break down complex curves into simpler equations using a parameter, facilitate visualization, easily describe motion or paths in space, like trajectories for example, enable generalization, represent curves that are not functions like circles or loops, allow flexibility, solve problems involving multiple variables or constraints independently. To find dy dx, we first determine dy dt, I'm assuming t is the parameter here, and dx dt, and use the relationship, which once again is just the chain rule. Dy dx is dy dt times dt dx. If you treat these as fractions, cancel out the dt, and what do you get? I know they're not fractions, but you can justify that you can treat them as such. Or dy dx is dy dt divided by dt dx, which is much the same thing.